In this video, we will work on factoring problems that have multiple methods embedded in them. Typically, it involves factoring out the GCF and then one additional factoring method. It could be difference of squares, sum and difference of cubes, easy trinomials. It could be any of those. So we're going to start with the first one, and I see that they both are even numbers, and I'm going to divide them both by 2. To me, the GCF looks like it's 2. So this becomes a 2 in the front, and then 4x squared minus 49. And then here, I can see that what's left inside of the parentheses is definitely a difference of squares. So I'm going to take the square root of the first term and the last term, and I'm going to make sure to include one of each sign. So I'm going to get 2x and 2x, 7 and 7, and there's going to be 1 plus and 1 minus. The 2 that I took out in the beginning, the GCF, is part of the final answer. So you just want to make sure you include the whole thing. In this next one, it's always my advice to put the polynomial in the proper order first, meaning the highest exponent. So I am going to rewrite this as 4x cubed minus 4x squared plus 32x. And just taking a glance at it, they definitely all have at least one x and a 4. So I am going to factor out the GCF of 4x. And again, factoring out the GCF just means we're dividing each and every term by the same exact thing. It's kind of like you're simplifying and making it smaller. So here I'm going to be left with x squared minus x and then plus 8. We definitely should check this trinomial to see if we can factor it. And I'm saying the factors of 8, we have 1 and 8. 2 and 4, neither one of those will give me a 1 here, so I would say that this is my final answer. We're going to do one more example. In a problem like this, I'm definitely looking for a GCF because there's just way too much going on. The other thing I notice is that the problem leads off with a negative, so that's definitely a sign usually to take that out with the GCF. The smallest exponent for the x's is x cubed, so that's the GCF for x. And the smallest exponent for the y's would be y squared. So I'm going to divide each and every term by that GCF so I can see what's left. And so the first one is going to become a positive 4x squared. Then it's going to be a positive xy, and then it's going to be a positive 9y squared. So I'm actually going to bump this over a little. And so I'm looking here at this trinomial, and one of the things that I notice is that the first and the last term are perfect squares. So to me, this might be a perfect square trinomial, but at the same time, oh, I'm missing my 12 here. Almost forgot that. So yeah, perfect square trinomial. So the square root of 4x squared is 2x, and the square root of 9y squared is 3y. And if I multiply those two things together, which would be 2x times 3y equals 6xy, and then double it, I do get the middle term, which fits the characteristics of the perfect square trinomial. So I know that this can easily factor into basically two things that are exactly the same. So the square root of 4x squared would give me the 2x. The square root of the 9y squared gives me the 3y. and these will both be positive, okay? It's not like the difference of squares where it's one of each. Perfect square trinomials, they have the same sign. It's either a plus plus or a minus minus. I am going to bring down the GCF that I have in the front, and that will be my final answer. So obviously, I still could have done it the long way and did 4 times 9, listed all the factors of 36, and went forward. This again is just like a shortcut if you recognize the pattern with the numbers.